So let's say that you guys want to make the next biggest thing, whether it's the next biggest website, app, game, etc. But you're just stuck and you don't know what to do. You don't know where to look and you don't know how to get started. So this is one of the biggest problems that beginners face when learning how to code, and that is just staring at an empty text editor, not knowing what to do next. And despite knowing all the basics of a given programming language, you know the basics of functions, conditionals, variables, etc. But it's still overwhelming as to how do you build towards the next step, to build towards the thing you want to build towards. And usually this leads into a cycle of constantly relearning the basics over and over and over again, which is a complete waste of time. So why is learning how to code hard, and what can we do to make it less hard? So one of the reasons why it's hard is because arguably you've never been taught creative problem solving.
So for example, let's take area. When you deal with a concept like area, we also provide a set of tools that the child is invited to experiment with in order to learn. So if area is what interests us, then one thing which is natural to do is to tile the area of this particular shape and simply count how many tiles it takes to cover it completely. And this little exercise here gives you a first sort of good insight of the notion of area. Moving along, what about the area of this figure? Well, if you try to tile it, it doesn't work too well, does it? So instead, you can experiment with these different tools here by some process of guided trial and error, and at some point you will discover that one thing that you can do among several legitimate transformations is the following one. You can cut the figure, you can rearrange the parts, you can glue them, and then proceed to tile just like we did before.
So usually in school, all you're given is just the final formula. Area equals width times height. You just plug and play two numbers, get something out, and you're done. There's not much creativity involved in this process. And it's rarely do you have time to get into how the formula was created, all the iterative failures it took to get to the final formula. In this case, it's just the area, but you can imagine something more complex, like the quadratic formula. How to bend the problem to adjust to the formula and vice versa, and how to create necessary problems to solve the bigger problem at hand. All right? So these are things that your school probably might have never taught, and it's just something that you're just going to have to pick up while you learn how to code. Another reason why learning how to code is hard is because human nature is working against you. So there are a lot of things that we humans do that are easy, automatic, and subconscious. Things like beating your heart or breathing. Those just happen automatically. Same for grabbing something off a shelf. If you want to grab something off a shelf, you just think about it and you just reach out and get it. But there are a lot of complex nuances when you think about this deeply. For grabbing something off a shelf, you don't think about what angle you have to angle your arm to grab the object, all right? Or how much force to apply to the grip of your hands so you don't crush the object, etc. And this translates terribly to computers because computers need all the details, all the nuances, all the precision, all the details, the minute details that you never thought of before. And to demonstrate this, there's a game online where you play Angry Birds using only code blocks. And you'll see how clumsy and detailed you need to get to think like a computer. So the last reason why learning how to code is hard is because programming education is just not that good. So let me put forth a few demonstrations to illustrate this point. So learning basic math. So without using a calculator, try to solve the problems on the screen right now, all right? No calculator. All right, so I'm assuming that you guys took a good swing at it. So 3 times 4 is 12, that's quite easy. 6 times 3 is 18. We've all memorized the 12 times 12 times table, so these two are pretty simple. But what about 13 times 5? That's outside my memorization range, but I can do it in my head. So 13 times 5, that's 15. Put the carry up there. 5 times 1 is 5, and then add the carry, that's 6. So 13 times 5 is 65. But the last two are more problematic, all right? 97 times 48, and 123 times 123. There's nothing inherently difficult about these two problems. I can do them, but it's just too much to hold in my head. I can't hold all the carries or the addition shift that you need to do and add all the numbers up together, right? It's just too much. So eventually, the problem reaches such a degree of complexity that you need to write things down to help yourself think. And if it's anything that you're going to take away from this, it should be this slide, all right? Because when you first learn how to code, you're juggling a lot of concepts. And even though those concepts are quite simple, right? The functions, variables, conditionals, etc., even though they're simple in isolation to understand, they're hard to juggle in unison to solve the problem at hand. Not to mention they're pretty sharp, because if you make a typo, well, it's a bug somewhere, potentially a crash. If you're just one number off, well, that's a bug somewhere, potentially a crash, potentially a security vulnerability, right? So again, it's really easy to cut yourself, and experienced programmers know how to duck, maneuver, and weave around problems. But to a beginner, it's really overwhelming as to, oh, there's a crash somewhere. I'm paralyzed as to what to do, right? It's just hard to hold all these things in your head. Think about it. We can't even hold multiplication in our heads when it gets to a reasonable degree of complexity. So what makes you think you can hold an entire program in your head, right? You can't. Experienced programmers, again, just know how to weave around problems that crop up. So let's contrast this back to learning math to illustrate a point, all right? So say you're learning addition for the first time ever, and you're just stuck on adding two numbers. Well, a technique that they teach you is that you can always hold out your hands and count up your fingers, and you can learn addition that way. Same with multiplication. Usually they give you all these worksheets, and you can just count up all the pictures, fill in the blanks, and you do these over and over and over again until you memorize multiplication, all right? Let's contrast this back to learning programming. When you learn how to code, the best advice is just, into the lines, then you go. Good luck, have fun. If you're stuck, Google it. That's the only technique I have for you. And while many programmers have learned how to code this way, right, and be passed down to the next people they're trying to teach, we can do a lot better. There are a lot of techniques that we can do to help people think and reason better about programming, because you're going to be thinking about things that you've never thought of before, creating solutions to problems you never had before, doing things that you've never done before, and it takes a lot of time and patience. And this is especially bad when you're in a school or university setting where there's a more stricter time limit and you're also graded on your solution. Because if you get a low score, it can lead you down to the wrong conclusion, like maybe I'm not good enough, maybe I'm just too dumb to get coding. And really, it's just going to take a lot of time, practice, and patience. So another problem that crops up is, where did you get that from? How did you come up with this? Where'd you pull this out of? Right? These are questions that are asked a lot when you're learning anything for the first time. And let's give an example for, say, when you're learning art for the first time. How does an artist know what to do? So here are a list of questions that you may ask an expert artist if you're a beginner artist, right? How did you know how to draw that smooth curvy shape? How do you know how to draw, all these perfect circles and ovals for the faces and eyes and etc.? How did you know what color to use and when? How did you know mixing this color and this color gives you this new color? How did you know what colors to pick when you're shading something, etc., etc., etc.? And if you were to ask an expert artist this, well, they're going to say, well, I don't know, it's just kind of obvious that it needs to be done this way. And really, it's just a combination of tracing, sketching, failing, and iterating that they developed a sense of obviousness. And same with learning how to code. Expert programmers would say, well, it's obvious that things need to be coded up this way because the problem says this, or, something that they've gained through experience. So this is Dreyfus's model of skill acquisition, and you start off as a novice, right? And as a novice, you want all these rules to help you when you're stuck. When you're learning addition, if you're stuck on learning addition, you can either grab out a piece of paper and write things down, or count up your fingers, right? That's a nice rule or technique to help you think better. But as you move up, you move towards intuition. And that's the most difficult part of experts teaching novices, because they have intuition developed from a lot of experience, and it's hard to convey that to a novice because, again, the answer is, well, it's just kind of obvious through all my experiences, which novices don't have. So you're a novice, or maybe you consider yourself an advanced beginner. Whatever the case may be, you're just stuck on the blank page syndrome, staring at an empty text editor, not knowing what to do next. We're at least going to get up to competent, proficient, and expert, or things that you're going to do on your own, alright? So how will we get up to competent? Well, we're going to use the design recipe taken from the book, How to Design Programs. And really, it's just going to teach you how to be more explicit about your reasoning process, rather than being very implicit. We're going to minimize the occurrences that you ask, how'd you get that from? Where'd you get that from? How'd you come up with this? All right? We're not going to hold everything in our heads. We're going to write things down and work through them systematically. So it becomes very apparent about where we're getting our baseline of reasoning from. When you're learning art for the first time, your baseline of reasoning is tracing. You got to get your hand used to the motion of drawing curves, right? In math, it's counting pictures. In programming, this is it. It's the implicit process that programmers run through in their heads, but we're just making it very explicit because it's really good for learning. So here are some words from Terence, a great mathematician in our current day and age.
You're thinking. It's actually, it's saying things out loud. It somehow forces you to think like at a more organized level than in your head, where it can be a bit jumbled and vague. And it's just more fun, you can go back and forth. And if you're stuck, maybe your co-author has a suggestion. If he or she's stuck, you can make a suggestion. You at least.
So yeah, human thought is often blurry, fuzzy, jumbled, and messy until we actualize them, until we vocalize or write things down, and that gives us a reflection process in which we can use to help ourselves think and improve, alright? Alright, so some final words of motivation. You're gonna fail, and you're gonna fail a lot, but it's the process of accumulating those failures and learning from them in which will help you to get good, alright? And I think Thomas Edison once said this before, I have not failed, I have only come up with 1,000 ways not to invent a light bulb, alright? And that's the process that you should be heading towards, the mindset that you should have towards learning how to code, or anything for that matter, alright? So learning how to code is hard because you've never been taught creative problem solving before, human nature is working against you, and programming education is just not that good.